Info, and today I'm going to show you a web application that monitor the state of the Rideau Canal Skateway. So it will monitor three different locale of this skateway, considering four measures: the ice thickness, the surface temperature, snow accumulation, and external temperature. So this is how the application will work. We have three devices, each for one locale, which are connected to an IoT hub, and then the IoT hub will send those metrics to a stream analytic for processing, and then stream analytics will send some data to storage account for archival. Indeed, it will send all the data processed to the storage account, and then aggregated data to Cosmos DB, and then Cosmos DB will send those aggregated data to a dashboard, and then the dashboard will be responsible to display the data. So I'm gonna quickly show the sensor app working. So this is the sensor app working, sending data, as you see here, to IoT hub. We have three different sensors identified by the name of the locale. So the sensor for legs down send data, for NAC and for fifth. Let's go through Azure and see how those components are connected and how they work. On IoT hub, throughout those metrics, we can see how that IoT hub is collecting data or receiving data from sensors, and then indeed we have three devices connected to IoT hub, represented each sensor. So sensor down, sensor NAC, and sensor fifth. And then when it comes to stream analytic indeed has input, which is IoT hub. Stream analytic is connected to IoT hub, as you see here. So yeah, IoT hub as input, and the output we have Cosmos DB for aggregated data, and the blob storage for archival. So this is the job running on stream analytic, and this is a query which will process data coming from the IoT hub, send processed data to both blob storage and Cosmos DB. Well, let's go to Cosmos DB to see receiving data. Data Explorer. Item, yeah. So these are data coming from stream analytics. As you see, data has been processed and ready to display through dashboard. When it comes to the storage account, it is responsible for the archiving of data. Historical data, Take the latest one. These are data coming from the stream analytics. So let's go through the web app. Dashboard. This is a dashboard running. So we have a different measure for each locale within the overall status of the application. For now, the status is caution, and then we have the 1 hour average for each measure across different locale, as well as the surface temperature, snow accumulation, and external temperature trends. So let's show the code. For the sensor, as I said, each sensor works in an isolated thread so that it can simulate the real behavior of sensor across different locale. So the config is responsible to retrieve configuration from the .env file, and domain define the sensor itself. LT client responsible to retrieve data from the Cosmos DB. So to send data to RT Hub. Yeah. And then workers will be responsible for launch each sensor inside the thread and define those sensor. When it's come to the dashboard, this is the server dashboard that contains query to retrieve data for the Cosmos DB. So this function here load the latest measure for location, and then APA get latest. As I said, we call the function. This is for the history, for the overall status of the application. And then when it's come to the dashboard itself, the public view, we have this app.js, which will be responsible for the behavior of the web page. Dashboard API endpoint. Let's go back to the server and see the API endpoint. So as I said, this is for the status, the overall status. It's for the history, the endpoint for the history, and then .env. This is the configuration variable for Cosmos DB. So in conclusion, I think the issue I figured out, as I said, I did not code the project. I defined the architecture, how the sensor will behave, and then ask for AI to implement the code. Even though I walked through some issues that takes a lot of time to get done with, but it's pretty much done.